Alright, so in this video, I'm going to solve the equation x to the power of 2 minus x to the power of 3 is equal to 80. So, to solve this equation, I'm going to first start by subtracting 80 on both sides. So now I get x to the power of 2 minus x to the power of 3 minus 80 is equal to 0. Now from here, I'm going to replace 80, negative 80, I should say, with negative 16 minus 64. Now, I'm going to rewrite this as, I'm going to first rewrite negative 16 as negative 4 squared, and negative 64 as negative 4 to the power of 3. And I'm going to group x squared with negative 4 squared, and x to the power of 3 with negative 4 to the power of 3. So now, there's two properties that I'm going to use. And before that, I'm going to write this as x squared minus 4 squared, and I'm going to group this minus x to the power of 3 plus 4 to the power of 3. We put this plus because this negative sign distributes. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. And if I have something in the form a to the power of 3 plus b to the power of 3, which is this is equal to a plus b times a squared minus ab plus b squared. So for x squared minus 4 squared, it's going to turn into x plus 4 times x minus 4. I have this minus a to the power of 3 plus b to the power of 3, or in this case, x to the power of 3 plus 4 to the power of 3 is going to turn into x plus 4 times x squared minus 4x plus 16. Now, because both of these terms have x plus 4 in them, I can factor out x plus 4. So I get x plus 4 times x minus 4 minus x squared minus 4x plus 16 is equal to 0. Now from here, this is equal to x plus 4 times x minus 4 minus x squared plus 4x minus 16. I just distribute the negative sign is equal to 0. And let's simplify this even more. I get x plus 4 times negative x squared plus 5x minus 20 is equal to 0. So I get two equations from this. I get x plus 4 equals 0, and negative x squared plus 5x minus 20 is equal to 0. So first, for x plus 4 equals 0, all we have to do is subtract 4 on both sides, and we get x is equal to negative 4. Now, for negative x squared plus 5x minus 20 equals 0, well, first off, we have a negative sign in front of x squared, so I'm actually going to get rid of that by multiplying both sides by negative 1. So I get x squared minus 5x plus 20 is equal to 0. And now, to solve this, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 5, and c is 20. So I get x is equal to negative of negative 5 plus or minus the square root of b squared, which is negative 5 squared, which is 25, minus 4 times a, which is 1, times c, which is 20, all over 2a, so 2 times 1. And this is equal to 5 plus or minus the square root of 25 minus 80 over 2, which is equal to 5 plus or minus the square root of negative 55 over 2. Now, this is equal to the square root of 55 times the square root of negative 1 over 2. And the square root of negative 1 is equal to the imaginary number I. So I get 5 plus or minus the square root of 55i over 2. So this is two more solutions to this equation. Thank you for watching. Please make sure to subscribe, leave a like, and share this to any of your friends and family. Alright, so in this video, I'm going to be solving the equation 8 to the power of x is equal to 88. So, my only variable in this equation is x, so that's what I'm going to be solving for. And now for my solution. I'm going to first start by rewriting my equation down here so I have a little more solving space. So my equation is 8 to the power of x is equal to 88. Now I'm first going to start by taking the log on both sides. So I get log of 8 to the power of x is equal to log of 88. Now, if I have something in the form log of a to the power of b, I can move this exponent b to the front, so this is going to equal b times log a. In this case, I have log 8 to the power of x, and I can move x to the front, so I get x times log 8 is equal to log 88. And the reason this property is so useful is because before, x was an exponent. And for our equation, if x is 1, I get 8. If x is 2, I get 64. And if x is 3, I get 64 times 8, which is 512. And we want to find what value of x results in 88, which is somewhere in between 2 and 3, but we don't know exactly where because it's going to be a decimal. So we can't really find the exact value as x when x is in exponent form. So this is why we can make it into a real term using this property, and now it's much simpler to solve for it. So now I have x times log 8 is equal to log 88, and I want to isolate x because that's what I'm solving for, so I'm going to get rid of this log 8 by dividing both sides by log 8. So now these two cancel out, and I get x is equal to log 88 over log 8. Now log 88, I can rewrite this as log of 8 times 11. So I have log of 8 times 11 over log 8. And now another property of logarithms is that if I have something in the form log of a times b, this is equal to log a plus log b. So log of 8 times 11 is going to equal log of 8 plus log of 11, and I have this over log of 8. Now, if I have something in the form a plus b over c, this is equal to a over c plus b over c, which is a simple fraction property. So log 8 plus log 11 over log 8, I can write that as log 8 over log 8 plus log 11 over log 8. Now, log 8 and log 8 cancel out to get 1. So I get 1 plus log 11 over log 8. So now all that's left is to plug in the actual values of log 11 and log 8 and solve. So log 11 is equal to approximately 1.04, and log 8 is equal to approximately 0.90. So I get x is equal to 1 plus 1.04 over 0.90, which is equal to 1 plus 1.16, meaning x is equal to 2.16. So this is my answer.